Hi students, I am Kailash. So I will be teaching you how to find the effective or total or net resistance whenever resistors are connected in parallel. In my earlier video, I taught you how to find the effective resistance or resultant or total resistance or net resistance for resistors connected in series. Now we will find the effective resistance whenever resistors are connected in parallel. So derive an expression to determine the net resistance or the effective resistance or the total resistance whenever resistors are connected in parallel. That's an important paragraph question. Okay, so now what I have here in the diagram are three resistors of resistances R1, R2 and R3 connected in parallel. If you look at all the left arms of the resistors, they are connected together and they form a common joint, say A. Resistors order left arms எல்லாத்தையும் நம்ம என்ன பண்ணிட்டோம் ஒண்ணா கனெக்ட் பண்ணிட்டோம். So similar terminals ஒண்ணா கனெக்ட் பண்ணீங்கன்னா I call it as parallel connection. Okay, opposite arms connect பண்ணோம்னா I'm going to call it a series connection, right? So all the left arms of the resistors are connected and I have a common joint, say A. And all the right end of the resistors are connected together and it forms a common joint, say B, a common junction, say B. So A is the junction point of the left terminals, so left side of all the resistors R1, R2 and R3. And B is the junction point of the right part of the resistors R1, R2 and R3. Okay, fine. Now the combination of these three resistors are connected to a battery whose terminal potential difference is V. And let I be the current supplied by the battery. Okay, now if you look at the resistor 1, the two ends of the resistor 1 are connected to the positive and negative of the battery through the junction point A and B. Therefore, the potential difference between the two ends of R1 will be same as that of the battery. So battery voltage R1 ஓட voltage same இருக்கணும். ஒரு component ஓட voltage battery voltage க்கு equal இருக்கணும்னா the two ends of the component should be in contact with the two terminals, that is anode and cathode of the battery, positive terminal, negative terminal of the battery. So only then the voltage across the component will equalize with the battery voltage. Right, now if you look at R2, the two ends of R2, the left end is connected to positive of the battery and the right end through the junction point B is connected to negative of the battery, which means the voltage across R2 and the battery voltage will be same. So B. Again, if you look at R3, the two ends of R3 through the junction point are connected to positive and negative of the battery. The left end of R3 is connected to positive of the battery and the right end of R3 is connected to negative end of the battery, negative terminal of the battery. So thus the voltage across R3 again will be same as that of the battery voltage. So if you look at the voltages across R1, R2 and R3, since both the ends of R1, R2, R3 are linked with positive and negative terminal of the battery, all the three resistors will have same voltage. Not only the voltage across the resistors will be equal to one another, it will also be equal to the source, that is the battery voltage. So I have to remember this point. So in parallel combination, the voltage across all the components will be equal to one another. They will not only be equal to one another, they will also be equal to the source voltage. Right. Now, let I be the current supplied by the battery. So you know the direction of current is always from positive terminal to negative terminal. Okay. So parallel connection, parallel circuits are somewhat, can also be called as branched circuits. Because if you compare battery supply பண்ற current, that is I, it starts flowing away from positive terminal. Now the current reaches the junction point A. So in இது வரைக்கும் the junction point A வரைக்கும் பாத்தீங்கன்னா the current flow, for the current flow we have got only one path. Now right from the junction point A there are three paths for the flow of current. One is the path provided by the resistance R1, the other one provided by the resistor R2 and the third path is through the resistor R3. Okay, so from the junction, right from the junction point A, the current I will branch off into 3. Since the resistances are different, எந்த பாத்துல ரெசிஸ்டன்ஸ் ரொம்ப கம்மியா இருக்கோ அந்த பாத் வழியா நிறைய கரண்ட் ஃப்ளோ ஆகும். எந்த பாத்துல ரெசிஸ்டன்ஸ் ரொம்ப அதிகமா இருக்கோ அந்த பாத் வழியா less current flow ஆகும். So through that particular path which has got the least resistance, more current will flow. And through that particular path which offers a very low resistance, large currents can flow. So in short I can say, if the paths provide different resistances, then the current flow through the paths will also be different. So that's why in parallel connection, the currents flowing through the components are different. This is because the components here, or the 3 resistors, are offering different resistances for the current flow through them. So that's why the current supplied by the battery branches off into 3 different values, I1, I2 and I3. So in short I can say, in parallel connection, voltages are same, but the currents flowing through the components are different. Why the currents are different? It's because of the resistance offered by the paths are different. Suppose if the 3 paths offer the same resistance, then again the current flow will also be the same. Okay, so don't forget this, right? Now let us start the derivation. I am supposed to find the net resistance. I am going to find the net resistance of R1, R2 and R3 which are connected in parallel. Okay, among voltage and current, whichever is different, we shall start from that particular quantity. See, current is different. So let us start from current. Okay, so the total current I supplied by the battery, let me write it here, breaks up into 3. I1, which is current flowing through R1, plus I2, current flowing through R2, plus I3, current flowing through R3. Now if you look at all these 3 currents, I1 reaches the junction point B, I2 after flowing through R2 reaches the junction point B, I3 after flowing through R3 reaches the junction point B. So at the junction point, all these 3 currents combine together. So I1, I2, I3 are நமக்கு break ஆகுது. Break ஆன I1, I2, I3 again at the junction point B என்ன ஆகுதுங்க, combine ஆகுது. So combine பண்ணி again the total current becomes I. So I is equal to I1 plus I2 plus I3. So that's why in any electrical circuit, I can say a junction to be a point from where currents will branch off through different parts of the circuit, or currents from different parts of the circuit can meet at that particular point. So electrical circuit la எந்த பாயிண்ட்ல இருந்து current various parts of the circuit க்கு branch off ஆகுதோ, or மத்த parts ல இருந்து flow ஆகக்கூடிய current அந்த particular பாயிண்ட்ல என்ன ஆகணும், meet ஆகணும். அப்படிப்பட்ட points that we call junctions in an electrical circuit. So at the point A, the current is branching off through these 3 parts of the circuit. Therefore, I am going to call A as a junction. And at the point B, in the 3 parts வழியா flow ஆகிற current என்ன பண்ணுது, beat பண்ணுது. Therefore, I am going to call B again as a junction. Right. So I is equal to I1 plus I2 plus I3. Now I am going to write I1, I2 and I3 in terms of R1, R2 and R3, for which I will be needing Ohm's law. Ohm's law. You know, Ohm's law is nothing but voltage is equal to current into resistance. I think I have told you a shortcut to remember Ohm's law. Vegetarian is equal to IR. So you know all IRs are vegetarians. So vegetarian is equal to IR. IR is safety படிச்சு பாருங்க. So vegetarian is equal to IR. Please remember this shortcut, don't forget. Right. So using Ohm's law, I will be writing I1, I2 and I3 in terms of R1, R2 and R3. So V is equal to I into R. Therefore I is equal to, rearrange this. So I get V by R. Right. So I1. What is I1? It's the current flowing through the first resistor. So current flowing through a component is equal to voltage across the component divided by resistance of the component, isn't it? So I1 is the current flowing through the first resistor. So what is the voltage across the first resistor? It is V divided by resistance of the first resistor is R1. So V by R1. Likewise, I2. This is the current flowing through the second resistor. So voltage across the second resistor is V and the resistance of the second resistor is R2. So I2 can be written as V divided by R2. Likewise, I3, current flowing through the third resistor. It is voltage across the third resistor, which is again the same V, and the resistance of the third resistor is R3. So V divided by R3. Now let me substitute these values in expression number 1. So thus expression 1 becomes I equals, instead of I1, I will be substituting V by R1 plus, instead of I2, V over R2 plus, instead of I3, V upon R3. Yaar common irukka the mono terms la voltage common irukku illaya. So let me take voltage outside. So I end up with 1 by R1 plus 1 by R2 plus 1 by R3. So let me take it as number 2. The individual currents in terms of R1, R2, R3 நாம் எழுதியிருக்கோம். அந்த மாதிரி இந்த total current we have to express it in terms of resistance. See, I1 is the current flowing through R1. I2 is the current flowing through R2. I3 is the current flowing through R3. So what is I? I is the current flowing through combination of R1, R2 and R3, because I1 plus I2 plus I3 gives me I. So I is the total current flowing through combination of R1, R2 and R3. Or I can say I is the total current flowing through effective resistance of combination of R1, R2, R3 will give me the total resistance of R1, R2 and R3. So I can say I as total current or current flowing through effective resistance of R1, R2 and R3. So in this circuit, I am going to replace R1, R2 and R3 by their effective resistance. Okay, let me put it here. And let me connect it to the same battery. And this single resistor, what I am going to call it as an effective resistor, should do the same job as that of the individual resistors. Which means all the three resistors put together allow the current of I ampere. So this thing should individually allow a current of I ampere. And each resistor had a capability of developing the source voltage. So this single resistor should be capable of developing the source voltage. So V. So if this thing happens, then I am going to call this single resistor as effective resistance of R1, R2 and R3. So let me take it as R. So since it's the total resistance in parallel combination, let me put a letter P in the subscript. So P stands for parallel. So R sub P is the effective or net or total resistance in parallel combination of R1, R2 and R3. So now let me write I in terms of RP. So I is equal to voltage across the total resistance is V divided by its resistance is R sub P. So let me substitute this over here. Let me take it as number 3. So substituting 3 into. So substituting 3 into. Okay. So I will get, instead of I, let me use V over R sub P is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Now let me cancel off V and V. So this implies reciprocal of effective resistance. Note that I am not getting the effective resistance. I am getting reciprocal of effective resistance. You have to be very careful in parallel combination of resistors, right? Okay. So the reciprocal of effective resistance is equal to sum of, we are adding. So sum of, what is that we are adding? Reciprocal of individual resistances, right? So the reciprocal of effective resistance is equal to sum of reciprocal of individual resistances. So that is what is going to happen whenever we connect resistors in parallel. Suppose if I have 4 resistors, you can extend this formula for any number of resistors. If it is at 4 resistors, then it will be plus 1 by R4. So if there are n resistors, it's going to be 1 by R1 plus 1 by R2 plus 1 by R3 plus dot 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 plus 1 by R sub n. Okay, now we'll just give some numerical values for R1, R2 and R3 and we will conclude. Okay, suppose if R1, R2 and R3 are the same values what we took in the series combination. Okay, let me take the same values. Okay, so 2 ohm, 4 ohm, and I think the third resistance was taken as 12 ohm if I am correct. I hope I am correct. Okay, so 2 ohm, 4 ohm and 12 ohm. These three are connected in parallel. Let me find the effective resistance. To find the effective resistance, first let me use this formula. Let me take it as number 4. So if I use formula number 4, the expression 4, I will end up with reciprocal of effective resistance, which on reciprocation will give me the resistance of the entire circuit put together, right? So 1 by R sub B is equal to 1 by 2 plus 1 by 4 plus 1 by 12. Now taking LCM, I get 12. 12 is the LCM. So 2 6 are 12, 4 3s are 12, 12 1s are 12. So 1. So I get 6 plus 3, 9 plus 1, 10 divided by 12. So this is 1 divided by RP. You have to be very careful here. Many students, they will write that for the total resistance is 10 by 12 ohm. Operation success, patient dead. So the answer what you have got is not the effective resistance, it's the reciprocal of effective resistance. So look before you leap. Swimming pool kulla dive adikkiradhukku munadi thanni irukka illaya adallam paathu dive adikkanum. Appo answer எழுதுறதுக்கு முன்னாடி நீங்க எழுதுறது effective resistance தானா அப்படிங்கறத செக் பண்ணிக்கணும். So the answer what I got here is the reciprocal of effective resistance. Therefore, to get the resistance, I have to take reciprocal on both sides. So let me take reciprocal on both sides. Okay, so Rp is equal to 10 by 12. When reciprocated will give me 12 by 10. Therefore, R sub P is equal to 1.2 ohm. So if you look at the effective resistance, it is smaller than the smallest resistance in the circuit. The smallest resistance is 2 ohm. And if you look at the effective resistance, it is found to be lesser than the least resistance in the circuit. So whenever resistors are connected in parallel, the effective resistance will be lesser than all the resistors. The simple as the effective resistance will be smaller than the smallest resistance in the circuit, which implies it will be smaller than all the resistors in the circuit. Okay, so thank you. Bye.